Welcome Statistics 1 students, this is week 2 of our maintenance. We're continuing to review some of the work that we should be aware of for the representation of data aspect of the course. So this one here, this first one, is actually a past exam question, I believe. So we've got a back-to-back stem and leaf diagram showing the values taken by two variables A and B. And we've got a key at the bottom which helps us understand what's going on. So 0.164 and 0.167, and we've got to find the median and the interquartile range. Okay, so the first step is to figure out how many we've got, pieces of data we've got, and these numbers here along the side tell us in each row how many we've got. So if we add them up, we've got 3, 5, 8, 20, 28, 33. I think it's 33. Let me just go back up the other way. 8 and 5 is 13, 25, 28, 30, 33. Yep, so we've got 33 pieces of data on in the A column. And so we want to find the midway point. Well, the midway point should be the 17th. So we go 33 divided by 2, which is 16.5, and then you just round up to 17. So we want to find the 17th piece of data. So we can count down from the top. 3, 5, 8, and then we want to go 9, 10, 11, 12, 13, 14, 15, 16, 17. I think this is the 17th. So there should be 16 on either side. So we can just do a quick check by, I've counted up, so I'll continue to count up. So I've got 3 here, and then we've got 8 here, so that's 11. And then 5 here, 11 and 5 is 16. So yeah, perfect. We're right in the smack in the middle there. So that's our median for A. So, all right, median is equal to 0.186. Okay, so we're going to look at the lower quartile now, and you can see that there's 16 pieces of data below the median. So the middle of 16 is 8 and 9. So we're going to look at 8 and 9, and then we're going to find halfway between them. So 3, 5, 8. So that's the 8th and that's the 9th. So halfway between those two, so it's 0.178 and 0.180. So I think it should be 0.179. And now we do the upper quartile. So for the upper quartile, we're looking at the top 16 pieces of data. Halfway there is the 8th and 9th. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So since they're the same, it's 0.198. And therefore we can say the interquartile range is equal to 0.198 minus 0.179, and that gives us 0.019. Okie dokie. Now, so the next bit is we're given for variable B that the median, so we're given the median, we're given the upper quartile, we're given the lower quartile, and we've got to draw box and whisker plots for A and B on this diagram. Okay, so pretty much the lowest number we've got is the 0.15. Whoops. Maybe I might make this a bit bigger to make it easier. So, oops, 0.115, 0.16, 0.17, 0.18, 0.19, and then 0.2. 0.21. I think we don't. Do we go as far as that? I think we're okay there. Okay. Brilliant. I could possibly even move that around slightly. Whoops. Okay, now I'll just leave it. Okay, so let's do A first. We'll do A at the top, and the lowest value for A is this one here, 0.150. So put a mark there, that's our lowest. And then our lower quartile what did we say is 0.179. So 0.179 is here, because each of those little squares is worth 0.002. So I'll draw my line there. I'm just doing this freehand, so it's not going to be perfect. Lower quartile. Now the median, of course, we found to be 0.186. So that will be here. That's our, whoops, there. This is our median. And then our upper quartile is 0.198, which is here. Just join that up. So within that box is our middle 50% of data. And then our top value, of course, is this 0.209, I think, 0.209, which would be about there. So we go all the way along to there. So this is A. And then we'll do B next. We'll do B with the blue. Now the lowest value for B is this one here, 0.151. So I think that's, or maybe that's not a particularly good color. Let's do brown. That's about there. Okay, and the we're told that the lower quartile is 0.164. So that is here. So the median, we're told, is 0.71, which is there. Sorry, it's a bit dodgy. You get the general idea. The upper quartile is 0.179. So just there. Again, you guys will have access to a ruler. I'm just trying to do this on the screen. Okay, and then the highest value we have is 0.204. 0.204 would be here. So where's 0.204? About there. Is that 179, 171, and then okay. So I think that's right. This is B. Just check that there, 0. Yeah, I think I'm pretty happy with that. I think that's correct. Median is 0.171. Yep, I think that's fine. Okay, so there we go. That's how to do those box and whisker graphs. You can see that there's quite a long tail here for A and one here for B, and that the spread is further in A than it is in B if you look at the boxes. Okie dokie, moving on. Okay, so the second thing we're going to do is we're going to find the mean and standard deviation of the following data. Now this time you can see that we've got a frequency table here. So a little bit different from the one that we did last week. The sum of x squared times f. So what that means is, well, let's do that. We'll do this bit here first. What does the sum of x squared f mean? Well, we're going to go, what have we got? X. Okay, so we've got 3 squared. And how many of those have we got? We've got 2. Plus 4 squared. And we've got 5 of those. Plus 5 squared, that's x squared. And we've got 8 of those. Plus 6 squared. And we've got 14 of those ones. And we've got 7 squared. We've got 9 of those. And we've got 8 squared. And we've got 4 of those. Then we've got 9 squared, and we've got 3 of those. So that is this bit here. Okay, so that's that bit. Now, and then, whoops, and then we're going to pop that all over the sum of the frequency. So we're just going to add all of these numbers here at the bottom together. So let's do that now. Let's see if we can do that. We get 5 and 2 is 7. 7 and 8 is 15. 15 and 14 is 29. 29 and 9 is 38. 38 and 4 is 42. And 3 is 45. So I think it should be 45. So that's this bit here, the sum of the frequency. Now we need to find the mean. How do we find the mean of this data? Well, mean is equal to the sum of fx divided by the sum of f. So we're going to go ahead and do that. So I'm just going to quickly chuck this in my calculator. So I've got 3 and I've got 2 of them, so that adds up to 6. I've got 4, lots of 5. I got 5, lots of 8. Or 8, lots of 5, sorry. I got 14, lots of 6. I got 9, lots of 7. I got 4, lots of 8. I got 3, lots of 9. And I think that adds up to 272. So I think it's 272. I'm going to divide that by what we said was the number of items of data, which is 45. So I'm going to divide that by 45 and I get 6.04 recurring as our mean. Does that make sense? Is the middle of the data roughly here? Yeah, that definitely looks about right if you look at the frequencies. So we're going to take 6.04 recurring, and then we take the square root of that. Alright, so we're going to chuck this into our calculator. Oh, wait a second, I just need a square there. Okay, so we're going to chuck this into our calculators, and what do we get when we do that? Well, I happen to get 1.48 for my standard deviation. Okay, that takes us to the last question here. So we've got a set of 20 items data. We know that the sum of all the values is 22. We know that the sum of the values squared is 55. We've got to find the mean and the standard deviation. Well, mean is easy because the sum of all the values divided by the frequency is equal to the mean. In this case, it's 22 over 20, which is equal to 11 over 10, which is equal to 1.1. Okay, now the standard deviation is equal to the sum of x squared over the number of items of data, subtract the mean squared. Now in this case, we know that the sum of x squared is 50, so we're going to go over 50, the sum of x squared is 55. I'm going to pop that over the 20 items that we have, then we're going to subtract the mean squared. Now when we chuck this into our calculators, what do we get? I'm getting 55, 20, what is that? Minus 1.1 all squared, square roots. I'm getting 1.24 as my final answer for the standard deviation. And that wraps that up for this week. Hope that makes sense. Hit me up with comments or questions in the comments if you have any. If I've made a mistake, let me know, which is highly likely. Talk to you soon. God bless.